Hello everyone, and welcome back to my channel. And today here, uh, I'm going to make you understand the concept of confusion matrix. Okay, and but before going deep dive into confusion matrix, I'm going to talk about what is accuracy and why accuracy is important. Okay, so accuracy in simple term means that how accurate it determines that how accurate a machine is. Okay, so if I give you the formula of accuracy, it is the total number of correct predictions divided by the total number of predictions. Okay, so let me write total number of correct predictions divided by total number of predictions. Okay, so total number of predictions include both the correct and the incorrect predictions of the machine. Okay, so this is what is meant by accuracy. Okay, and why accuracy is important, as it helps to distinguish between different models. Okay, so distinguish between different models is important. And if I give you an example, let's suppose I have a model called M1. Okay, I've trained that model and it gave me the accuracy of around 0.9. And then I trained another model called M2. Okay, and it gave the accuracy of around 0.8. So naturally, I will lean towards M1 as it is giving a more accurate prediction than M2. But here's the catch. Okay, so as accuracy, as you can see that accuracy is important, but the confusion matrix goes further beyond accuracy, and confusion matrix also tells us that where the model is actually getting the wrong predictions. Okay, and if I give you a classification example of email spam filtering. Okay, so an email may be a spam and not a spam. Okay, so these are only the two categories. Now if I talk about confusion matrix. Okay, so by giving you an example through email spam filtering, I will now make you understand the different terms that are used in this confusion matrix. Okay, first we have to look at the actual labels. Okay, so actual labels are those labels that determines what in actual if I give an example of email spam filtering, then actual labels tells us that email is actually a spam or not a spam. Okay, and these predicted labels are just that the machine predicted. Okay, now if I now as you can see this four quadrant. Okay, so our confusion matrix is essentially, you can see that it is divided into four quadrant. Okay, first one is actual positive. Okay, now first, if we move from clockwise here. Okay, this is the first, this is the second, this is the third, and this is the fourth quadrant. Okay, first I'm going to talk about actual positive. Okay, so confusion matrix tells that actual positive is defined as that. Now if I take an example of email. Okay, so actually the email is defined as a spam. Okay, and the machine also told that this email is a spam. Okay, so this is what is meant by actual positive. Okay, and if I move clockwise to the actual negative. Okay, so first I will make you these two terms understand, and then uh, the rest, this false positive and false negative. Okay, now if I move towards actual negative, what it means is that actually the email is not a spam. Okay, in reality the email is not a spam, but the machine predicted that it is also not a spam. Okay, so this is what is meant by actual negative. Okay, which means that the machine predicted correctly. Okay, so now if you can see these two terms. Okay, actual positive and actual negative, so these account to the total number of correct predictions. Okay, so if I write somewhere here, what is uh, what is the total number of correct predictions. So I think- so our total number of correct predictions is the actual positive plus of actual negative. Okay, so this is what is our total, this is the correct prediction, and this is also the correct predictions. Okay, the first and the third quadrant. So you have to remember this. Okay, and now if I talk about false positive. So uh, an email is actually not a spam, but our machine predicted that it is a spam. So this is what is meant by false positive. Okay, so it is the incorrect prediction that is given by our machine. Okay, and now if I move towards false negative. So false negative, in this our email is actually a spam, but the machine predicted wrong that it is not a spam. Okay, our machine predicted that it is not a spam. So this is what is meant by false negative. Okay, now if you can see in this second and fourth quadrant, we can see that machine is giving an inaccurate prediction. Okay, and now if I give you if I take a, if I take an example of M1, okay, that is giving around 0.9 accuracy. Okay, so around that the 0.1 will be either false positive, false negative, or it may be a combination of both. Okay, so let me clarify it further. So why we are using these terms is that now we are actually able to see that where our machine is falling short. Okay, where our machine is predicting that are predicting it is a spam, but actually it is not a spam, or it is the opposite, like actually the email is a spam but our machine is predicted it is not a spam. So it goes into depth. Okay, where the machine is predicted wrong. Okay, now if I write the incorrect prediction. Okay, so our so the machine incorrect prediction will be the false combination of false negative and false positive. Okay, so this will be the machine incorrect prediction. Okay, now you have understood this. Okay, and now you may be wondering like why we are going so deep into this. Okay, so let me make it clear that this is actually important, as there may be many critical application. Like if I take an example of healthcare. Okay, and in that we are, let's suppose we are making a COVID application. Okay, so for a COVID application we have to see that where our machine or where our model is falling short. Okay, so as like if our it is like by if I take you if I make you go through an accuracy, only accuracy. Okay, like that it is somewhat our model is giving around 0.8 accuracy, our COVID model. Okay, but we have to see that where the machine is falling short in that 0.2. Okay, in that 0.2 value. Okay, whether our machine is going towards false positive or it is actually predicting false negative. Okay, so like in short, in summary, I have to we are basically learning this because we have to also check the criticality of the application, and where our model is falling short. Okay, we cannot just determine through accuracy that our model is good or it is bad. Okay, we have to actually look at these labels. Okay, so now so this was all about confusion matrix. Okay, and I've also created a plot here. Okay, so you can check the code. Okay, but now if I show you this. Okay, I've created a confusion matrix here. Okay, so in this screen you can see that COVID-19 diagnostic confusion matrix. Okay, so here also we can see that these are the labels. Okay, that I talked about here. Okay, so in this like it is like these labels can be here I've written actual positive. Okay, but here you can see that true actually it is negative. Okay, so these labels, like it can be interchanged, but now like you can understand that here true negative means that a person is healthy, and also the machine predicted that it is healthy. Okay, and similarly here you can see that true positive. Okay, that is the our machine correctly predicted that the patient is sick. Okay, so this is but we have also to look at a false positive and false negative. Okay, where the machine is failing. Okay, where the machine is going wrong, and it may miss some sick patient. Okay, so this is important. Okay, so through I've just give you one example of COVID application, but there may be a countless example where the confusion matrix is essential. Okay, and we cannot just determine through accuracy alone. Okay, that a model is good or bad. Okay, so through the combination of confusion matrix and accuracy. Okay, we have to then we can truly understand that where our model is going wrong. Okay, now if I give you now an extended definition of accuracy. Okay, so first thing that I wrote was just the basic, that total number of correct predictions divided by total number of predictions. Okay, now if I to clarify it further, what our correct prediction is including is that it is including true positive as well as true negative. Okay, this is what our machine is including in correct predictions. Okay, and divided by total number of predictions. Okay, So what will come under total number of prediction is that it will include the all these four quadrants, okay, all these four categories, okay. So let me write here. So now it will include of true positive, okay, as well as true negative, okay. It will now also include the incorrect predictions, that is that it is false positive and false negative, okay. So this is what the extended definition I've given of accuracy, okay. So this was all about it, okay. So I gave I gave this first I talked about why accuracy is important, okay, as it helps to distinguish between different models, okay. Next thing I talked about is like I gave you an example, okay. So here accuracy may be useful, okay, like in distinguishing between different models. But we have to also move beyond accuracy and see that where the machine is actually failing, okay. So here I told about false positive and false negative, okay. It is simple and like you have to go through it once again. So I talked about through email spam filtering. I gave an example and talked about what is the meaning of all these four terms. And also then I talked about the total number of correct predictions, how we can write which is the actual positive and the actual negative, okay, and the incorrect predictions, which is the false positive and the false negative, okay. So this was all about it. I hope you enjoyed the video. If you have any doubts, you can write it in the comment sections, okay. So thank you and goodbye.